D-ribose keeps appearing in food science, biochemistry, and ingredient lists because it isn't a trend term. It's a naturally occurring simple sugar with a clear identity across those contexts. At the chemistry level, ribose is a pentose monosaccharide, which means it's a single sugar unit with 5 carbon atoms, and its formula is C5H10O5. The form you actually see in nature is D-ribose. L-ribose is the mirror version, but it isn't found naturally. More specifically, D-ribose is an aldopentose. That means it belongs to the 5 carbon sugars and carries an aldehyde group in its linear form. So chemically, it's a ribose within that aldose family. It also doesn't stay in just one shape. You can see D-ribose as a linear structure, or in ring forms called ribofuranose and ribopyranose, which are the same sugar arranged in different structures. Here, the D label comes from one specific checkpoint. You look at the chiral carbon farthest from the aldehyde group and use that position to assign the sugar's family. For ribose, that arrangement lines up with D-glyceraldehyde. That's why the sugar is named D-ribose, not because of direction in space overall, but because it matches that reference configuration. That same molecule also shows up in scientific references, where databases classify D-ribose as a fundamental metabolite and a human metabolite. And when you move from research into the marketplace, you'll see it listed as a food, nutraceutical, and biochemical ingredient, which is why the name keeps resurfacing in so many real-world contexts. For ingredient supply, industrial D-ribose is typically made by fermentation using transcatolase-deficient bacillus strains, which are tuned to channel metabolism toward ribose production. In that process, glucose is fed into the fermentation system, converted into D-ribose in the broth, and then the ribose is purified into the ingredient form used downstream. From there, the broth moves through a finishing train. It's filtered, decolorized, ion exchanged, concentrated, crystallized, dried, and then packaged as the usable material. What comes out is usually a white crystalline powder, supplied with the standard documentation buyers expect, including a COA, a TDS, and an SDS. In supplier catalogs, D-ribose is usually pinned down with standard identifiers like CAS 506091 and the formula C5H10O5, then grouped by specifications such as food grade, nutraceutical grade, or biochemical grade. Those same listings often spell out where it fits in practice, like food additives, dietary supplements, and formulation work, so buyers can see the commercial use cases at a glance. When D-ribose is sold commercially, the spec sheet usually spells out the measurable basics like assay and purity, along with moisture, particle form, and the storage conditions needed to keep the material stable. On the label itself, you'll often see the name D-ribose paired with practical traceability details like the grade, the batch number, and the compliance information that tells buyers exactly what standard that lot is meant to meet. So when D-ribose shows up in papers, databases, and ingredient catalogs, it's the same idea coming into focus from different angles. A naturally occurring simple sugar with a defined place in both science and manufacturing. If you're using it for formulation, don't stop at the name. Check the grade, review the COA, TDS, and SDS, and make sure the material matches the job you need it to do.